As part of the Weather Service task, we take it very seriously to understand exactly the impacts and in which ways the communities are affected by these events. So we sent two teams to do damage survey the next morning, and in the coming days, we also sent a total of four teams that we did analysis. We look at the damage in part to try to determine the intensity of these tornadoes, was also to have a closer look at all these tragic moments that our Floridians were going on right after these tornadoes. One of the people that were in the most affected area, the Wellington Palm Beach Gardens, which was hit by an EF3 tornado, was our meteorologist-in-charge, Robert Molleda. We want to bring Rob out today because you have a lot of pictures, Robert. You talk to people. You were there on the ground. And what can you tell us, first of all, the purpose and the importance of doing these damage surveys, and then take us real quickly on the steps that we take in terms of analyzing, doing the investigation, and then eventually assigning an intensity to these tornadoes.
Yes, thank you, Tony, and good afternoon to everyone on social media watching us. Thank you for joining us. And yes, the warnings that were issued on October 9th were obviously really, really important. That's what helps to save lives. Another very important component of this process is to go out and do damage surveys. A lot of the times when we do damage surveys here in South Florida, we don't know the exact cause. We don't know if it was if the wind damage was caused by a tornado or whether it was caused by what we call a microburst or a straight line thunderstorm wind. However, as Donald mentioned very well, we had a lot of video evidence. We had a lot of pictures that these were tornadoes, in addition to what we're seeing on radar. So the main goal of the survey was to rate the tornadoes. In other words, assign it a rating based on the intensity, which is based on the damage caused by the winds. So if you look here at the screen, we have scales that we use. So for tornado ratings, we use what's called the Enhanced Fujita Scale, EF. This scale has been in use since 2007, and it's a scale that's based on the damage, and then there's an estimated wind speed range attached to that. I'm sure all of you are familiar, or at least have heard of the Saffir-Simpson Hurricane Wind Scale. That is a purely wind scale that's based on the either measured or estimated winds around the center of the storm. Whereas again, the EF scale or the Enhanced Fujita Scale is really based on the damage, and then we assign it a wind range based on that damage rating. So I'm going to show you here some pictures that we took during the survey to give you a sense of what we look for and how we come up with these ratings. This picture was taken in Wellington, so this was the last tornado of the day. It was an EF3. And this damage here, if you look back here, really what you see just a lot of rubble and debris. This was what was a double-wide manufactured home. You can see the structure is basically unrecognizable. And also you notice here there's a tree which suffered extreme damage. It lost almost all of its branches. The trunks even got split or broken. So these are what we call damage indicators. So we have a toolkit that assesses the level of damage to certain structures like buildings, homes, etc., as well as for trees or power poles, and then we assign it the rating that way. So we take the pictures, we analyze them, and that's how we come up with the rating. So this one, based off the level of damage here to the structure as well as to the trees that were right next to it, it was assigned an EF3. Now a little farther north in Palm Beach Gardens, we had a home here, fairly new, probably no more than 2 years old. I'm just guessing here, but this was a fairly new community in Palm Beach Gardens. But you can see the level of damage to this home. We had a lot of the roof that was damaged, or a lot of the tiles were removed. Windows were broken, garage door blown in. This was rated right on the border of an EF2 to EF3, so right on the borderline. Again, these are estimates. We will never know for sure how strong the winds really were in this area associated with this damage. In the same area there in Palm Beach Gardens, here's another home. This home actually had been completed but not yet moved in, but suffered a lot of damage. Here you can see part of this wall here just caved in and collapsed. A big part of the roof got damaged. As you're going to see, the next picture shows the back of this house. So you're going to see how extensive that roof damage really was. In fact, here it is right here. So that was the front. This is the back. Look at the back. The entire back part of the roof got lifted off. And there's also, looks like, some walls here that were knocked down in this home. So again, we have a toolkit that will assess or give us an approximate wind speed or an estimated wind speed based off what we assign, what we observed, the level of damage, how much of the roof was damaged, were there walls knocked down, how extensive was the tree damage, etc. Here's a picture. We have some pretty heavy tree damage here along this median, and then over here on the side of the road we have a car that was flipped and actually lofted about or over 100 yards from its original location. Now, one of the damage indicators that we don't use are vehicles, because there's a lot of factors that can play into whether a vehicle gets lifted and gets thrown. It's not just wind speed. Obviously, wind speed is a factor, but it could be also the angle of the wind hitting that vehicle, the weight of the vehicle, obviously. There's maybe some other factors that we don't really quite understand. So there's no damage indicators that we use at this time specifically for vehicles. Now we're going over to Lakeport. This is on the west end of Lake Okeechobee in Glades County, where we had another team that surveyed. This was an RV that was lifted and was thrown up against this tree. The undercarriage of the RV was twisted around this tree here, and you can see the very heavy damage to the tree as well. And even here, it looks to be a palm tree here, which was totally knocked down. So this was rated an EF3. Again, staying in the Lakeport area, another EF3 rated damage point here. This was a home that lost its entire roof, as well as the front porch. Again, with severe damage. Again, staying in Lakeport, this home here, you can see a large part of the roof totally removed. And one more important damage indicator here was this tree right here. You can see all that's left of it is maybe a 5 or 6 foot portion of the trunk. So this tree was literally split in half. It takes a lot of wind to do that. So that's one of the damage indicators that we use that matches up one with the other, which gives us a little bit more confidence, or a bit more confidence, in the rating of this particular damage point here. Again, some more pictures from the Lakeport area. Again, this manufactured home here in the background, completely destroyed. And then this palm tree here, bent all the way down to the ground. Again, pretty consistent with EF3 type damage. So again, heavy tree damage here. Unfortunately, something that we saw quite a bit with this tornado in Lakeport, as well as with the Wellington Palm Beach Gardens tornado. And finally here, this home, this was a 2-story home. The top story was completely destroyed, and you can see some of the debris from it lying here. Now, one of the things about this event, one of the many things that was so out of the ordinary for South Florida, was not just the number of tornadoes, but also how strong they were. Again, we had 2 EF3 tornadoes. The vast majority of tornadoes in South Florida are EF0s and 1s. So we do get quite a few tornadoes in Florida or in South Florida, but the vast majority are in the 0 and 1, which still do damage, but on a much lower scale relative to something like an EF3, for example, which we had 2 of on October 9th. So that was one of the really most remarkable aspects of this event. And again, we talked about how many tornadoes we had. 15 tornadoes in the southern Florida region alone, and there were more farther up the state. But those 15 in South Florida, that was the most in one day in our recorded history. Very important to point out, when we have, whether it's directly hit by a hurricane or flooding, or in a case like this where we have damage from a tornado, is there's the instinct, and I totally understand that people want to go out and check the damage, right after that storm or that event passes over your house. But we have to be very careful when we do so, because there's, as you've seen with all the pictures, there's a lot of debris out there. We have pieces of roof and tiles and other things here lying on the street, which, we have nails and screws and other things that are really dangerous. Not to mention power lines here that are actually down. We have power poles on the ground and power lines hanging down. These wires are probably live, so it's just very, very dangerous to be out there. So we have to really, really be careful and use caution after these events. And we talked about how important the surveying is from the standpoint of rating tornadoes, but it's also one of the big important things about going out and doing a survey is talking to people that are there. Getting additional information from them. For example, did they receive the warnings that we sent out? What time do they remember the tornado going through? So getting that additional information, really just talking to folks and trying to understand what they're going through. It's really difficult to do, but when you're, for example, in this situation here, you have a home, and literally minutes before, everything was normal, and then everything changes a minute later or 2 minutes later after that tornado goes through. So that's one of the most difficult parts of doing a survey is, we're scientists, but we also have to relate, and we also have to understand what these people are going through. So we're very sensitive to that. We want to make sure that we don't get in people's ways, but at the same time, we are collecting important information that's going to help us better understand the science of tornadoes for years to come. So with that, Tony, I'll take it back to you